Welcome to IT Pro TV. I'm your host, Don Pizzette.
Coming at you live from San Francisco, California.
You're watching IT Pro TV.
Hello, and thank you for watching IT Pro TV, helping you learn everywhere you go. I'm your host, Zach Memis, for this episode of CompTIA Linux Plus. This episode is manipulating text, and I can think of no better manipulator than Don Pizzette to help us out. Don, good to see you.
I've been refining my skill over years and years. So in this episode, we are going to look at manipulating text, which you'd be surprised. You actually find yourself doing a heck of a lot when you work with Linux boxes. As you sift through log files, as you review configuration files and so on, you deal with a lot of text on your screen. And in most Linux distros, there is a suite of utilities that are available that let you change the text, twist it, turn it, sort it, rearrange it, delete, do all sorts of crazy things. And it's incredibly useful. So those are some of the things we're going to look at right here in this episode. We'll get to learn a little bit about sed and awk. We'll talk about wc and a handful of other commands that just kind of need to become part of your regular routine Linux administration toolkit. Now, for an end user, they're not usually going to mess with this stuff. They'll just open up a graphical editor. But when you're in a command line and you're sifting through configs or logs especially, these commands will come in super handy. So that's what we're going to be looking at right here in this episode.
So Don, let's start simple. How can we get text on our screen?
All right. So in scripting, when you're writing a script, it runs and it does things in the background. And oftentimes you want it to show something on the screen so that you know that it finished. So there's plenty of times where we need text to display on our screen. Now, your applications may already generate that for you, but you can do it yourself using a couple of different commands. So we'll start with a really simple one here, which is the echo command. So the echo command basically just says, take some text and show it on the screen, right? When you're interacting with the shell, there's actually two different I/O devices that you're interacting with. One is on the input side. You have what's called the standard input, or STD in, and then you have the standard output, or STD out. The STD in is you interacting with the shell. So like I'm typing the word echo. This is kind of me doing input into the shell. But then I'm going to tell this command to show something. So I'm going to do a quote mark here, and then I'll give it a phrase. I'll just say, or actually I'll do a single quote. Hello, whoops, world. There
You're going to say, hello, kitty.
Well, you know, hello world, that's our standard. If you've taken any programming 101 course, like the first program they make you write, Hello Kitty would be a little more fun.
It would.
So anyhow, so I'll run that. Now, what I'm doing is taking the word, or the words, hello world, and providing those to the standard input. Echo then takes them and echoes or copies them to the standard output. The standard output is my screen. And so when I run that, I get a message back saying, hello world, right? If I had just typed hello world like that, I get an error, right? I provided it the standard input, but there was nothing there to handle it. So the echo command is what actually handled it. It grabbed it and it provided it on the screen. Now that's a super simple example, but I wanted to show this because in between the standard input and the standard output, we can do all sorts of things. We can manipulate the text and change it. In fact, echo is really simple. You give it one string and it throws it on the screen and that's it. There's another command called printf, right? And again, if you've taken programming 101 for any language, usually a string printing command is one of the first functions that you learn. If I do a man printf though, and pull up its document, see how it says format and print data. It can take the string that we're providing it and it can format it. It can change it. It can do things like make it bold or underline it. It can enter in carriage returns. That's how I usually use it. If I want to do multi-line output, it can do that. And so if you read through, you'll see all the different things, like right there, new line. If I want to, I said carriage return, but it's really a new line. To move, important difference here when you manipulate text. Carriage returns and new lines are both ways to kind of get to the next line. Technically, a carriage return doesn't really move you to the next line. It moves you back to the beginning of the line that you're on, and then new line moves you to the next one. In the Unix and Linux world, all you need is a new line. New line moves you to the next line and moves you to the beginning by default. In the Windows world, you actually need both a carriage return and a new line to take you all the way back to the right spot. It's a little difference between the operating systems. But either way, printf can do either. You see, I've got both options. You can insert tabs and all sorts of other things. So, for example, if I wanted to say, hello, what's your name, right? But I wanted it to be on two lines. Well, I could run two echo commands, and that would do it. Or I can just use printf, and I'll come in and say printf, and then in quotes, I'm going to say hello, period, right? And that's going to be my first line. And then I'm going to enter in a new line command, /n. We just saw that in the man file. That's where that came from. So I'll say /n, and then what's your name? Question mark. All right. And I'll, whoops, darn it. Sorry, hit enter by accident. And I'll close out that quote. Okay. Now, when I do that, notice how I did a /n and there's no spaces, no space before it, no space afterwards. The slash is a character that lets printf know, hey, I'm about to give you a special character. And then the n gets interpreted as the character turn. If I put spaces around these, it would still work, but there would be a space before what's your name and it would look offset on the screen. So we have to kind of keep that in mind. It's one line here, but printf is going to change that. And now it comes out as 2 lines. In fact, it didn't even do another new line for my command prompt. See how my command prompt got offset? So I should probably add another /n right there at the end. And now when I run it, hello, what's your name? And then I'm back at my prompt and I'm able to interact. So that's an example of printf, not just taking the text that I'm giving it, but taking it and expanding it, right? Changing those /n's into new lines or whatever it is that we're trying to do, tabs, bold, all sorts of other crazy stuff. Printf is actually a really, really powerful utility if you get in and learn about it.
What is an example of what we can do to the text?
All right, so right here, I didn't really change the text. I just kind of manipulated its positioning, right? But we can actually change the text. We can do a lot of different things. In fact, maybe we're not even really concerned about the text itself as much as we are concerned about like statistics about the text. Let me give you an example. So right here, oops, let me get in the right folder. Here we go. I've got a couple of documents. And earlier in one of our earlier episodes, we were messing around with Dracula.txt, right? So we've got the full text of Bram Stoker's Dracula sitting right there.
Again.
Have you, it's very, very useful.
It is.
So, have you ever wondered how many words are in Dracula, in the full text of Dracula, right? Or whatever. If you need to do a word count, if you want to do a line count or a character count, that kind of stuff. I don't necessarily care about the text itself. I want to know stats about the text. And so I can use the command WC, which is short for word count. But word count, it can actually do character counts and other things. And I can point that against a file, or I can even send text into it using the standard in, standard out to be able to get counts like that. So if I run WC and I point it at Dracula.txt, it's going to run and I get 3 numbers back. Okay. And each number is representing a little bit of information about this file. So we've got, for example, the byte count or how big the file is. Then we have the character count and the word count. So it looks like we've got, I must have those backwards. So we've got 164,000 words. That seems a little excessive, doesn't it? Let's pull up the man file for that. I might have my column numbers backwards. So when you take a look here, you can actually tell it exactly what you want to see. So as far as how many characters or lines, words, what it is you want. I wanted a word count. And then I got confused, and I can't remember which one of these columns is the actual word count. I'm going to assume that it's the smallest number, really. Actually, the line count should be the smallest. Word count should be next. Character count should be the biggest. But we could filter that down a little bit. I can do a WC-W, like I just want the word count for Dracula. And there we go, 164,381. It was the middle number. So this was my line count was almost 16,000. My word count was 164,000. And then my character count, 883,008. That's a lot of characters, a lot of typing. So, that's an example of kind of looking at the statistics. I'm not changing the text, but I am still working with it. I'm still manipulating it in a way. I'm just converting it down to summary numbers.
Okay, so can we actually change the text, Don?
We can, yeah. Not with WC, right? That one's not going to do it. In fact, with Echo and printf, we can't really change it, right? Echo is just taking the text and throwing it on screen. Printf might explode some special characters, but that's about it. WC doesn't change anything. It just outputs stats. But there are other commands that let us change the text in different ways. Some ways are significant and permanent. Some ways are temporary. So let me give you an example. The sort command. Sort is a neat command because it lets you take any kind of text data and sort it alphabetically, ascending, descending, or whatever you want. You kind of reorganize something. And that's pretty handy. If you're looking at like log files, for example, log files are normally sorted by date and time. But if you want to sort it based on a service name, so all the service data is up front or something like that, you can use the sort command to change that. Now, The sort command is temporary. It's just taking the standard in, which would be your log or text file, reorganizing it, and then putting it out changed in the standard out. So the original file is left untouched, but you can choose to to save that to a file, and your new file would have the changes, and it would be manipulated. So you kind of got a few choices there. But if you look, you can do things like dictionary order, ignoring leading blanks, and all these different things that can kind of mess with how things get sorted. There's even a month sort, which is really handy because the months, at least on the calendar that we use in the US, is not alphabetized at all, right? Like I think April should be the first month that we were going alphabetized, and they're not. So you can specify all sorts of neat things in here to make it change the way that text works. What I find really useful with sort is you can even sort by things other than the very first letter, right? So for example, here in my directory, I have a little calendar file. I think I used it in another episode, but I've got it right here, and it's a couple of holidays for 2019, right? And each holiday is listed with the date first, numerically, followed by the name of the holiday. Now, if I were to sort this, the default is to sort based on the very first character. And if there's a tie, like, whoops, let me zoom in on this a little bit. If there's a tie, right? So like, let's see here. I guess Christmas and New Year's. They're both in December, right? So they both start with a 1. That's a tie. Then it moves to the next character. They both have a 2. That's a tie. Then it goes to the slashes. Well, that's a tie. Then it goes to the day and it finds that 2 versus the 3, and so it knows Christmas comes before New Year's. That would be the default way to sort. Now, my text file's already sorted that way, so I don't really need a sort utility to do that. But if I want to change it and kind of manipulate that, I can come in and use the sort command and get it outputted in a different way. What you can do is you can just type sort and then specify the file that you want to sort. So I want to sort that Cal 2019. And when I run that, I get the same data output, right? Because that's the default sort order. It's already sorted in the order that we want. I can add a -R though, and that will reverse it, okay? And sort the other way around from the highest number to the lowest number. And when I run that, there's my text. I've got New Year's Eve as first, all the way down to New Year's Day being last. It's in the opposite order. Now, the original file's unchanged. This just changed the output on my screen. Where we can get really cool on this stuff is we can say, I want to sort by something other than the first character. Maybe you want to sort by the day or the year. Maybe you want to sort by the name of the holiday, right? If I want an alphabetized list of the holidays, they're in here, but it's like the, I don't know what, 14th character or something in that list. So if I want to sort by that, what you can do is you can tell the sort command that your data it's in a columnar format, right? It's like a table. And mine kind of is a table, right? On the left side, I've got the date, and on the right side, I got the name of the holidays, right? Well, you got to look for what's in between those values. In between the date and the holiday, I have a space. You might have a tab or a comma or something. That's called a delimiter. And the delimiter is just identifying where we're switching from one set of data to another set of data. And you can tell sort to skip a certain number of delimiters and sort by the next value that's out there. So if I tell sort, I'll just say sort dash K2. K, it stands for column, even though column starts with a C. So K is column. I'm telling it to
column.
Yeah, it's a strange one. I don't know exactly how they pick which letters to use for this stuff because I don't think -C is used for anything. But anyhow, so basically, I'm telling you I want to look for column 2. The date is going to be column 1. The name of the holiday is going to be column 2. Problem is, how does it find column 2? I have to tell it what my delimiter is. And to do that, we say -T, T for delimiter, I guess. But anyhow, whatever the string is, followed by whatever that character is. Yeah, it's all over the place. So if this was a CSV, if it was a comma-separated values file, I would just do a comma right here, and it would know I'm doing a comma. If it was a semicolon, right? Some people do that. I could put that in there, or whatever it is. Some people do tabs, so I could do a tab character here. In my case, it's a space, right? And since it's a space, I have to put it in quote marks, otherwise it's not going to find it. So I'm just going to do a quote, space, and a quote, so it knows that that's what my delimiter is. And then I'm going to point it at that file, Cal 2019. So it's going to know my delimiter. That's going to separate it into columns, and then it's going to know that I want to sort by that second column. And when I run that, now I get my output right here, alphabetized based on the holiday name. And so I can see Christmas is first, then Halloween, Independence Day, each one listed. And I could even stick that -R on there like we did before, and we'll get it in reverse order where Thanksgiving comes first, Christmas comes last, and there's the holidays. So sort command, really powerful for this stuff. We can even go a step further. There's actually a sister command to sort that works very similar. Sort is reorganizing data. Sometimes I don't care about the order. I just want a particular piece of the data. Like, what if I just want the holiday names? I don't want the dates. Just give me the names. I want a list of holidays, right? And I can output that, but maybe I just want that second column. I don't want the first column. Well, we can use the cut command. Cut will say, take some text, remove part of it. Just cut out one piece that I actually want. Now, the cut command works very, very similar to sort, except the command line options here are different letters because consistency would be crazy. So
it would be too much.
instead of calling them columns, cut calls them fields. So I've got the date is one field for me and the name is another field. So I need to say -F2. I want the second field. I just want the holiday names. And then I need to tell it a delimiter, which they do -D. That makes a little more sense, right? So D for delimiter. And I need to tell it what my delimiter is. Well, in my list, the delimiter is that space. So I'll go ahead and designate that. And then I can point it at my calendar file. Okay. And when I run that, now I get a list back and, ooh, I got a little problem. All right. My problem is I've got numerous spaces in several holiday names, right? And so now things have kind of broken a little bit. With sort, it returns the entire line. So I didn't notice that problem, right? But inside of cut, it's just returning the piece that I want. And so I have a couple of holidays here that are new something, right? I guess New Year's Day and New Year's Eve, right? But I just get the new piece. So I need to fix that. Turns out the space character is not a good delimiter because we use it so much. And that's why you see most people use CSV files, right? If I edit my calendar, and actually, let me do this. I'm going to copy my calendar to a file. I'm just going to rename it .csv just so I remember that's what it is. And then I'm going to edit that. And what I can do is we can just run through right quick and basically just change these little spaces so that they're commas. There's actually a faster way to do this, but I'm just going to do it manually. There we go. So now I've got commas, and that's going to be my new delimiter. And so when I rerun that cut command, now I won't need quotes for this anymore. I can just say D comma. So look for a comma, and that's my separation. And when I run that, it's going to jump in and return my holidays. Now, in my case, it didn't actually, I said I didn't need it in quotes. Maybe I do. So let me put that back in quotes. Oh, I'm pointing at the wrong file. So I forgot. I renamed it CSV. I actually said that out loud, but then didn't pay attention myself. So when I point at the right file, there we go. I get it. It finds the commas, and it returns those values, and everything comes back properly. Again, the cut command didn't change the source file. The source file still has everything, but now I'm getting just the text that I want. And that's a pretty powerful thing to do.
So, Don, if we've modified a file, is there a way that we can go back and compare it to the original before the modification?
Yeah. All right. In another episode, we took our Dracula file. Actually, we still have it here somewhere here. Dracula.txt. So Dracula.txt was written by Bram Stoker. The villain in it is a vampire named Dracula. I think everybody probably knows that, right? So if I start taking a look at that Dracula file and I go in here, you'll see the name Dracula pop up a number of times because, well, it's his story.
He's
right?
in there.
Well, we changed it to Kermit the Frog in another episode. So I've got another file here, Kermit.txt. And when I look here, what we should see, I thought we changed it, but I just saw, let me just search for Kermit here. There we go. So I can see Castle Kermit, Count Kermit, right? So we changed it. Well, what I did here is I opened it up in Vim, and then I did a search for the word Kermit, right? So I kind of went through a few steps to be able to find that. I'm really having to search over and over and over again to find each instance. But there's a neat command called diff. And diff will let you see the differences between two files. You can compare two files, and it will just show you what's not right.
Are they side by side, Don?
Sort of. It kind of lays them out in a weird way. Let me show you because it'll make more sense if you see it. I'm going to start by just saying diff and then pick a file and then pick a second file, right? And the order of the files doesn't really matter because it's going to do a full two-way comparison. But the output, what we see in a moment, because Zach asked, is it side by side? It's not. it's going to show with little arrows that point to the left and to the right. So you need to remember which file is first, that's the one on the left, and which file is second, that's the one on the right. So the arrows point towards the file order. So if I run that, it's going to return all of the differences between those two files. And I can see this list right here. Whoops, if I scroll down a bit, here we go. And it shows me, here's a line on the left, Castle Dracula, as there are no maps of this country as yet to compare. And then in the file on the right, Castle Kermit, as there are no maps of this country yet to compare. And as we keep going through, you'll just see that over and over again. Dracula jumping onto his feet and Kermit jumping to his feet. It's all right there. This is
somehow Dracula has more impact.
yeah, Kermit doesn't strike fear into the hearts of mortals.
No, not fear.
So this is super handy, especially when you're doing configuration files, right? Anytime I modify a configuration file, I'll normally create a backup. And when I say create a backup, it's nothing fancy. I usually just copy it to a file and end it .bak. And then if I go and make changes, I can use the diff command to compare the backup configuration file with the new configuration file and just see immediately, all right, what did I change? What did I mess up? And it will show you things that were added, things that were changed, deleted, right? In my case, there's really just things that were changed. So, something was modified from Dracula to Kermit. But if we go a little fancier, like if let me take that Kermit file, and let's say I'm going to delete the very first line. Okay, so I'm just going to delete that line out of there. All right, and we'll rerun the diff. When we run it, it'll actually show that that line's missing. So as I scroll back up to the top, so right off the bat, see how it says on the file on the left, line 1, that's what this 1, 2, C1. So on line 1, I've got the Project Gutenberg ebook of Dracula. But in the file on the right, I've got nothing. It's missing, right? And then the line numbers are off after that. So it's showing on the file on the left, I'm on line 9. On the file on the right, I'm on line 8 when I get to the title because I deleted a line. So it's keeping track of that, and it shows you all that information. So on every one of these now, you'll see the line numbers are off by 1. It keeps track of that, but still matches everything up perfectly. So really powerful, especially for verifying configurations.
So Don, are there more advanced tools available for text manipulation?
Absolutely. There's some tools that are really, really well historically known in the Unix world. Sed and awk. 2 utilities that are incredibly powerful and incredibly not user-friendly. Like they're really, really hard tools to use. But you can achieve just about anything. In the early days of Unix, they didn't have a text editor. Like nobody had written a text editor, and so they ended up creating one called Ed or Edlin, which I don't even know if we have it in our distros anymore because this was 30, 40 years ago. But one of the early text editors was one called Sed, which was a stream editor that would let you take data that was moving through standard in and standard out and edit it and change it. But it's really hard to use because it expects you to do everything in a single command. Imagine if I wanted to go through and do a bunch of edits and add some lines and I had to do it in a single command. That would be really hard to do.
Oh my gosh, yeah.
Awk is a similar utility, which is designed to manipulate text. It's a little bit more modern, still really hard to use. And it's designed not so much to edit a file, although you can with it. It's really designed for search and replace type operations, but you can do it in bulk across tons and tons of files all at once. So for most people, they're going to use the commands we talked about earlier in this episode or use the Vim editor or whatever. But if you ever have to do automation, if you have to automate searching for text or editing a file or whatever, Sed and awk are going to be the 2 big ones. Now, we could probably do an entire 5-day course just on those 2 utilities. But let me just kind of show you in brief so you're familiar with them. On the exam, they just want you to be familiar with the utilities. So let's start with awk. Most of these utilities stand for something, the name. In this case, the name awk, AWK, is just the first letter of each of the developers' last names. So it's Aho, Weinberger, and Kernighan. I don't have that memorized. That's probably right. Anyhow, so that's where awk came from. And with it, you can basically point it at some text, and it can manipulate that text in a way. Let me just show you. Sometimes it's easier to show. So I have a file. Let me just cat the file here called softwarelist.txt. And it's a list of, software. So I'm trying to keep track of what software I've installed, what version it's at, and then whether or not it's been installed versus configured. Maybe they've been both. Maybe I've installed it, just haven't configured it yet, or so on, right? So I've got it laid out here in this file. And this might be output from a command that you run or whatever. It doesn't really matter where the text comes from, but I've got some text. And when I look at it, I see all this data in here. Let's say that I just want information about Apache. I don't want to sift through this whole file. I could just locate a particular line. Well, now I know today, like if I wanted to just find Apache in here, I would use grep. Grep is a great way to search that. You can use regular expressions. But there was a time when grep didn't exist. And in that time, awk was the kind of go-to command. With grep, I've got to take text from somewhere. So I usually use like the cat command and then send that text to the grep command. Well, with awk, it can do it all in one. It's one command. It's more efficient, and it's harder to use, but it's more efficient, and that makes it better for scripting and automation. So if I wanted to just point at this file and just get Apache, well, if I pull up the man page for awk, what you'll see in here is that it's got a very, very storied history. They even kind of mentioned it right up here in the beginning, that it was part of one of the original POSIX standards applications. Oh, I could have cheated. They had the developer names right there. Anyhow, so basically they kind of lay that out. But as you look at it, you'll see there's there's a ton of options and stuff. It's not an easy command to learn.
No.
But at the basics, if I just said, look, give me any line that starts with Apache, what I can do is I can feed a regular expression into awk, and it'll use that regular expression to find the lines that I want and then return them. So I could come in and say, for example, awk, and then for the regular expression, I'm going to do a single quote. You got to put a single quote around it. And then I'll do $1, right? So I'm telling it that I want to find the first set of information. And I'm looking for lines where the first set of information is Apache. And I'm putting that in double quotes. That's why I had to do the single quote earlier. So this will all map out right. And so I'm looking for Apache. And then I have to do a single quote to close that out. So I'm looking for any line that starts with Apache. That's what I want to have returned to me. And I can point that at the software list, and it runs, and there's the line, right? This functions just like grep, except instead of having to do two different commands, it's all just done in one, and it returns it. Now, this is a really simple example of what awk can do. You can do things like substitutions. I can say, look in this file, and when you return it, do these kind of changes and modifications. For me personally, I really don't use awk very much because I'll use grep instead. But if I want to do manipulations, if I want to change something, grep doesn't do that for me. And that's where sed comes in, the other utility. Now, sed actually does stand for something. It stands for stream editor. We can take a stream of text and we can edit it. And like its name implies, it's really good at it. So here's an example of where awk and grep don't necessarily meet our needs. In fact, what most people do is they use awk to generate the data that they want, and then they use sed to modify it. So you'll see those two, sed and awk, they get used a lot together. If you ever want to go and buy a book on these, you'll usually find the books that cover both technologies. But if I want to use sed, sed is also complex. And I mentioned earlier, it's because it's expecting you to try and do everything here in a single line, which is pretty difficult to do. But if I want to, for example, let's say that I want to get my list of software, but I don't want Apache. I want Apache left out. So now I'm going to edit this. I'm going to say I've got this text, and I'm going to edit. I'm going to knock out a line that has Apache. Okay. Well, the way we would do that is we would come in and we would say sed, and then I would do a single quote, and then I'm going to do not a regular expression. Well, I guess it sort of is a regular expression. This is going to be more like Vim. With Vim, remember how we could do search and replaces by using forward slashes? That's what I'm going to do here. I'll say forward slash. I'm going to look for Apache. And then another forward slash, I'm going to tell it what to replace it with. I could replace it with another text string if I wanted, but I'm just going to do the letter D. And that letter D, that tells it I want to delete any line that has Apache. So that's a basic search operation, but not a replace. And then I'm going to point it at that software list. And when I run it, I get my software list back, and it's missing Apache, right? So I loaded the file into RAM, sed edited the file while it was in RAM, and then output it to my screen in this edited form. So that's what it does. That's just a real simple example. If you Google around on sed, you'll find people do really amazing things with the command. It's very, very powerful. But that's basically what it does. And just so you know, like how to kind of know this for real life as well as the exam, when you're modifying a file, you're typically going to use Vim or Nano, and they have search and replace and things that are built in there. Even from the command line, a lot of times you'll just use grep if you're trying to find something, right? Those are your go-to commands for interactive actions. But for scripting and automation, That's where SED and awk come in. They're super handy and really powerful.
Awesome, Don. Thanks so very much. Manipulating text. I know I learned a lot. I hope you did too. I'm sure you did. And before we move on, Don, what else would you like to say?
Some of these commands might seem kind of silly. You don't necessarily care about them, but the more you work in the world of Unix administration, and this is Linux, BSD, even Mac OS, when you drop to the terminal, you'll find that you use these commands a lot. They're really a lifesaver, especially if you're working on servers that don't have a GUI. But on a desktop, don't hesitate to use your GUI tools. A lot of times they're easier and faster, but when you're doing things in bulk, what we've seen here in this episode really shines.
Great advice. And here's some more great advice. Make sure you watch every single episode of CompTIA Linux Plus. You're going to be very glad you did. It's going to help you now and in the future. And by the way, you need to keep studying now. You don't stop there. There's all kinds of supplementary information in our course library. And it's there to do one thing, help you be even more successful. So check that out too. And tell everybody you know about IT Pro TV. IT Pro TV is binge-worthy. Thanks for watching. I'm Zach Memis.
And I'm Don Pizzette.
We will see you again soon.
Thank you for watching IT Pro TV.